Hello and welcome everyone to yet another week of QM. Now let's take a break from talking about numbers, how to calculate their mean and variances, and how to calculate index numbers from them, and talk about probability, which is going to be today's topic. Now before we start to discuss probability in detail, I have an announcement to make, and that is that you're going to have your first in-class test next week. That is specifically the week starting on October 21st. And please note that it is part of your formal assessment. So your performance and the marks that you get in this in-class test will be included in your mark for QM and will be included in your transcript. So this is a serious matter. The topics that will be covered are going to be from teaching week 1 till teaching week 4. So fortunately, or maybe unfortunately for some of you, this week's topic will not be included in class test number 1, but that does not mean that you can now just close this video, because this week's topic will be assessed in class test number 2 that you're going to have much later on in this semester. So let's now get back into talking about probability. So the agenda for this week is as follows. So we're going to talk about what probability means and the related concepts included in probability, and then we're also going to talk about the basic operations that we can do in trying to compute the probability of something or another, and those include things like sets and combinations, permutations, and etc. Before we go ahead and start computing the probabilities of various things, it's very useful to be aware of the concepts and the definitions of various things within probability. So broadly speaking, the probability of something is just the likelihood or the chance of whatever it is that we are interested in of happening. An experiment is just this activity that we're interested in and this activity that we are trying to conduct. A sample space is just the space of all possible outcomes that could be the result of our experiment. And an event is a small part or a small subset of this sample space that we are particularly interested in studying or knowing about. So consider this example of an experiment, which is rolling a die. If we were to roll a die, our sample space or the outcomes that we are able to observe are 6 mainly, and those are 1, 2, 3, 4, 5, and the number 6. And the events that we might be interested in studying or knowing about, for example, could be rolling a number 1, or rolling a number that is less than 5, so 1, 2, 3, 4, and rolling an even number, so that's going to be 2, 4, or 6. Now, when we want to calculate the probability of this event from occurring, what we'll have to do is we'll have to calculate or count the number of ways that this specific event that we're interested in that can occur, divided by the total number of outcomes that there are in our experiment. And events could only have one element, such as the case when we want to talk about rolling a specific number, for example 1, or it could have many elements. For example, rolling a number less than 5, in that case there are 4 elements, or rolling an even number, in that case we have 3 even numbers on a die. So probability is just a numerical measure of the likelihood or the chance that a particular event will occur. It ranges all the way from impossible, that is 0% probability or chance, all the way to certain, which is 1 or 100% probability or chance, and all the things in between. That means I cannot have negative probability, and I cannot have a probability greater than 100%. So let's just go ahead and compute the probability of the 3 events that I gave as an example. So all what we have to do again is compute the number of ways that our particular event can occur. When we're talking about rolling a number, let's say 1, there's only one way, and that is if that number shows up. So in that case, it's just 1 divided by the total number of outcomes. That's going to be 6. Let's look at the second event here. That is rolling a number less than 5. So on a die, we have 4 numbers that are less than 5. That's going to be 1, 2, 3, and 4. Divide by the total number of outcomes, again, which is 6. So in this case, the probability is going to be approximately equal to 67%. Lastly, let's look at, for example, the probability of rolling an even number. We have 3 even numbers divided by the total number of outcomes, which is 6. So in this case, the probability is 50%. Let's look at yet another example. So suppose we have a box, and in there are 12 marbles, right? So 6 plus 3 plus 2 plus 1, 12 marbles. And now we're interested in the probability of picking a red marble. So what do? First, we calculate or count the number of outcomes that result in a red marble. That's going to be 3. Then we're going to divide by the total number of outcomes that we have, which is 12. So in this case, the probability of picking a red marble is 25%. And in general, if there are n experimental outcomes, then the sum of all of these outcomes, the sum of the probabilities of all of these outcomes must be equal to 1. It should always be equal to 1. It cannot be less, it cannot be more. So in our marble scenario, if we computed the probability of each outcome occurring individually, and then if we sum them up, we should get the number 1. And here are yet other examples of different experiments that we can do and their outcomes that we have and their sample space corresponding to those outcomes. When we are trying to count the number of ways that a particular event can occur, sometimes it's going to get a bit wieldy, so it's very helpful to be aware of some of the techniques that we can do to help us or to speed us in our calculations. So the 3 types that we're going to be discussing this week are the multiple step, then combination, and then permutation. In a multiple step experiment, we are essentially repeating the experiment k number of times. So if we want to figure out the total number of outcomes that we can have, what we'll have to do is figure out the outcome of this experiment in each step and then multiply it by the outcomes in other steps. So if we were to consider tossing a coin twice, then first we'll have to consider tossing the coin once, and then we're going to have to consider tossing the coin again. So in this case, we're going to look at step number 1 when we're tossing a coin. So we only have 2 outcomes for it, so it might end up with a heads or a tails. And then in step number 2, we consider tossing the coin again. So again, we're going to have either a heads or a tails, right? Given that, for example, in our first step, we had a head or we had a tail. So in total, the total number of outcomes that we have are 2 in the first step, multiplied by 2 in the second step, for a total of 4 outcomes. As a result, our sample space is going to be 4, as you can see from here. Right, so here is a self-training task. Find the sample space for rolling a die 3 times. I want you to do this right now, so pause the video, I'm going to wait, and once you have finished calculating the sample space, we're going to continue. Right, okay, so are you back from calculating the sample space? Did you pause the video and calculate the sample space? Are you sure? Because if you have not paused the video and calculating it, you're only deceiving yourself. Okay, anyway, let's go and continue our discussion of this week. Are you sure? Because if you have not paused the video and calculating it, you're only deceiving yourself. Okay, anyway, let's go and continue our discussion of this week. The next thing that we will discuss is combination. So consider this example. In a classroom, a lecturer randomly picks 2 out of 5 students. Let's say their names are Alisher, Begzat, Clara, Davran, and Eva, and ask them a question, right? So in this group of 5 students, how many combinations of 2 students can be selected? So notice that the sequence of selection does not matter. That is, if I picked Alisher first and then Begzat, that is the same thing as selecting Begzat first and then Alisher. Now, if you were to consider all the options or possibilities that are available and write them down in a piece of paper, you are going to have 10 possibilities. So basically it is Alisher with Begzot, Alisher with Clara, and so on and so forth. Notice that I have not written Begzot with Alisher here because that's the same thing as writing Alisher with Begzot. Right, so the formula for a combination is as follows, right? And here we have small n number of objects to be selected from a set of large n objects where the order of selection is not important. So that is the crucial part of a combination. And the formula is as follows. So what you have here is large n factorial divided by small n factorial multiplied by the difference between large n and small n factorial, where n factorial just means multiply the number n with all the numbers that are lesser than it all the way to 1. So for example, 5 factorial is just going to be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which in this case is equal to 120. So if we were to apply this formula using these numbers, what we're going to get is 5 factorial divided by 2 factorial multiplied by 3 factorial. So in this case, these 3 numbers cancel out. This 4 reduces to the number 2. This 2 moves or goes away. So that's going to be 5 multiplied by 2, which is going to be 10. Notice we get the same result, but this is a more systematic way to calculate arbitrarily large small n and large n numbers. Then let's talk about permutation. The difference between a permutation and a combination is that in a permutation, the order of choice matters. So let's consider this example. Again, in that same classroom, out of those same 5 students, how many ways can we have one interviewer and one interviewee? So notice, for example, in the first pick, which is here, if I select Alisher to be the interviewer and Begzot to be the interviewee, that's not the same thing as selecting Begzot to be the interviewer and Alisher to be the interviewee. Now again, if you were to write all these options down, you're going to have 20. But let's consider a more systematic approach using a formula so that we can plug in any large number that we are interested in. So a permutation is just basically small n number of objects are to be selected from a set of large n number of objects, where now in this case the order of selection is important. And you're going to see this formula over here. So the formula for a permutation is just large n factorial divided by the difference between large n and small n factorial. Notice that the only difference between a combination and a permutation is that in a combination we are dividing by small n factorial, whereas in permutation we don't have that figure over here. So if we were to apply this formula using these numbers again, so we're going to get as follows. So that's going to be 5 factorial divided by 3 factorial. So these 3 numbers cancel out. So we just have 5 multiplied by 4, in this case 20. And notice that usually a permutation is going to be larger than a combination due to us not having that n small factorial over here. Right. Okay, so now let's talk about operations with events. So generally speaking, we are going to be talking about 3 such operations. The first one being the union. So the union of events A and B is an event which just contains all the outcomes belonging to A and to B, or both of them. So in our Venn diagram that I have over here, the union of A and B is just going to be this big circle over here and this circle as well. Right, so where was it? Then let's talk about intersection. The intersection of A and B is just the event that contains all things that are included in both A and B. So in our Venn diagram, the intersection of A and B is going to be this thing over here. And finally, the complement of an event A is an event that consists of all outcomes that are not included in A. So in this case, a complement is just going to be all these things we have over here. That is something that is not included in A. Right, so let's consider this example here. So we toss a die and then we observe the number that appears on top. Our sample space is going to be 6 over here. Then we might have different events that we are interested in. So for example, event A is just an even number occurring, event B is just an odd number occurring, and event C is a prime number occurring. So A union B is just the event that either an even number or an even number or a prime number occurring. B intersection C is just the event that an odd prime number has occurred. And C complement is the event that a non-prime number has occurred or observed. And you have these 3 exercises down here for you to just compute for yourselves. So now let's talk about relationship of events. When we say that 2 events are mutually exclusive, what we're saying is that A intersection B is equal to 0. That is, these 2 have outcomes that are not included in the outcome space of the other. Right? When we talk about a dependent event, what we're saying is that, for example, event A has an influence on event B. Right? So for example here, probability of A given B is equal to the probability of A intersection B divided by probability of B. And finally, when we're talking about independent events, what we're saying is that one event has no influence on the probability of another event from occurring. So in this case, for example, probability of A given B is just equal to the probability of A. That is, here event A has no influence on event B. Then let's talk about the addition rule for a union. So consider this question over here. In QM, for example, let's suppose that there are 600 XIFS students, of which 480 have passed the in-class test and 450 have passed the final exam, with 390 students passing both of these assessment components. Right, so let's just say, hypothetically speaking, due to this high failure rate, the module leader just decides to give a passing grade to any student who has passed at least one of the 2. So now what we have to do is compute the probability of passing this module. In this case, we have to compute the probability of a student passing either the final exam or the in-class test. So specifically, that's going to be the probability of A union B. And the formula for that is just probability of A plus probability of B. However, we are double counting a small subsection of those that occurred in A and B at the same time. So we're going to have to remove that double counting thing that we have done. So the probability of passing the in-class test is this, which is 80%. Probability of passing final exam is 75%. And the probability of passing both the in-class test and the final is 65%. So the probability of passing either the in-class test or the final is going to be 90%. Then we have the multiplication rule for an intersection, right? And it is used to compute the probability of the intersection of two events. So if we want to talk about probability of A intersection B, that's going to be the same as saying probability of B multiplied by probability of A given B. And this is derived from this over here, from dependent events. And the multiplication rule for independent events are just going to be probability of B multiplied by probability of A. Finally, let's talk about mathematical expectation. So for example, let's say this website has sent us the following offers for the coming El Clasico game, depending on who you bet. So if you bet that Barcelona wins, they will triple your money. If you bet that Real Madrid wins, for example, they will double your money. And if you bet that the game results in a draw, they will quadruple your money. So if we would like to bet $100, then what will be the expected sum of my money, assuming, of course, that these probabilities that might occur are equally likely to occur. So my possible earnings are just going to be 200 or 0 if I bet on Barcelona, 300 or 0 if I bet on Real Madrid, 400 or 0 if I bet on a draw. As a result, my expected sum from betting here is just going to be $200 multiplied by 1 over 3, because that's the probability of it occurring, plus $300 multiplied by a third, that's the probability of that occurring, plus $400 multiplied by a third for the probability of the third one, which in our case, the expected sum of our bet is going to equal to 300. So this is it for this week's discussion regarding probabilities. So today we just discussed the basic concepts and the different types of operations that we could do, and the union rules and intersection rules, and etc. Okay, then, see you guys next week, and don't forget to be prepared for your in-class test.